Okay, so today we're on lesson 5.2-2, which is our second day of verifying trig identities. Now, what we're going to do today in class is I'm actually going to do 3 of your homework problems for you, but you're going to try them first, and they're going to be all sorts of ones that look roughly like this. They look ugly. Remember, when you're verifying a trig identity, what you've been given is an equation, and it will be an identity if it's true for all values of the variable. So what you have to do is you have to leave one side of the equation alone, and you've got to choose which side you're going to leave alone, and you work with only the other side of the equation, and you're not allowed to change it. All you're allowed to do is change how it looks. So all you're allowed to do is replace things with things that they are equal to. And you keep on doing that until you end up with, say you were changing this side, you'd have to keep on changing it till you ended up with this side being 1 over 1 minus cot x, okay? So that's how you verify a trig identity. There are various different ways of doing it. We went over these yesterday. This one, obviously, you've only got one fraction on each side, so you're not going to be doing things like combining fractions over a common denominator. Nothing is squared. You've got no distribution, multiplying factors together to do. You've got nothing is already multiplied, so you can't factor anything. Because you've got no factors, you can't cancel. So basically, at this point, to start this problem, you're left with just really these 2 ideas as your starting point. So what you can do is you can either use the technique where if you see anything that isn't a sine or a cosine, then you replace it with using either its reciprocal identity or its quotient identity, and so that the only things that you're writing down are sine or cosine. That's how the technique works. For instance, this cotangent of x, yes, it could be replaced by the reciprocal, which is 1 over the tangent of x, but that wouldn't help you. Okay, type into chat quickly, what could you replace cotangent of x with? What is it equal to? Everybody type into chat now. So one technique would be the sine cosine technique on this one, because these are already sines and cosines. You wouldn't work with this side. You'd work with this side, and you would replace the cotangent of x with its equivalent, what it's equal to. So you look at your identities and you go, okay, cotangent x equals cos x over sine x. So that would be a starting point if you were using this technique. If you were using the conjugate technique, you're allowed to multiply anything you like by the number 1. So as long as you choose a carefully chosen form of 1, where you're multiplying by something divided by something else and they're both the same. So what you could use as a starting point on this is to multiply by the conjugate of this. The conjugate of 1 minus cot x is 1 plus cot x. But you're only allowed to multiply by the number 1. So you have to use a fraction where the numerator and the denominator are the same. So you'd have to multiply the numerator by the same thing. Then you haven't changed it, you'll just make it look different. So now what you're going to do now, you're going to take 2 minutes, and it doesn't matter if you end up going down a rabbit hole, just try. I want you to try either this technique or this technique on this problem, and just see where you get to in about 2 minutes. Off you go. Okay, so I know something that you don't. I can look at this and immediately go, no, I'm not going to use that technique. I'm going to use this technique. Now, you don't know that yet, and about 10 minutes into the lesson, I'm actually going to tell you what I see that tells me what to do that. But I want you to actually experience trying to do these on their own. So I'm not going to multiply by the conjugate. I'm going to use the sine cosine technique. So I'm going to work with this side and leave that side alone. So my only option is to replace this with something it's equal to, and we've already established that the cotangent of x is the cosine of x divided by the sine of x. So that's where what I'm going to write in that place. But obviously I'm going to do it more neatly than that. So let's do this problem now. So on the next line down, I write down something that is exactly equal to the line above. So I've replaced cotangent with cosine x over sine x. Okay. Now, what I'm going to do is I want to sort out this fraction. I've got a fraction inside a fraction. Be careful that you know which is the fraction bar. When you've got a fraction inside a fraction, sometimes you lose track of which is the dividing line between the numerator and the denominator. Okay? Now, when you've got a fraction inside a fraction, you always want to try to get rid of that. So what you're going to do is you're going to do division of fractions, which I know you know. Lots of people say this perfectly, but they can't do it. You're going to multiply by the reciprocal. And I know a lot of my students say that perfectly, but they don't do it right in practice. There's another way of saying it that might help. When you're multiplying by the reciprocal, what you do is you keep the numerator as it is, you keep the numerator, change from division to multiplication, and then you flip the denominator. Keep, change, flip. So what we're going to do is we're going to keep that numerator as a 1. We're going to change that division into multiplication, and then we're going to have to flip the denominator. So we have to flip that upside down. But can you see at the moment, we can't flip it upside down. To flip something upside down, this has to be one fraction. And it's something minus a fraction. These two terms here have to be brought together over a common denominator so I can flip them upside down and create the reciprocal. So this number 1 here, I'm going to rewrite as an equivalent. Now I want them both to have the same denominator, so I'm going to write this 1 as the sine of x over the sine of x. Yeah, that's still worth 1. That's what I'm doing on the next line. So this is going to be, my problem becomes 1. I've got the division line, and then I've got this fraction where the denominator is going to be the sine of x, and I've got from the second fraction, I've got the minus cosine of x, but this 1 here was the sine of x divided by the sine of x. That's giving me a sine of x here in the numerator. Now I've got one fraction in the denominator. See, I'm using color here because I've got 2 fraction bar lines here. And this is when students really get confused, which is the numerator, which is the denominator, and you need to keep track of that. So I'm going to keep the numerator the same. I'm going to change, so keep the numerator, just done that. Change division into multiplication. So this division, I turn into multiplication, and then I flip the denominator, so I flip this upside down and write its reciprocal. Then, remember, we're trying to prove that this side is the same as the other side. So go back and have a look. And can you see we were there? That's what we had to reach. So write out your identical twins. This side, the whole way down, has been sine of x over sine of x minus cos of x. Now, I know they're not absolutely identically written at the moment, but I hope you know math well enough to know that 1 times something means it's the same thing. So you can be really sneaky here if you wanted to and just kind of delete that thing. Pretend you saw it from the beginning. Yeah, that's cheating bit. Or you should probably really write out the whole line again. Okay, so that's that one. And we use the technique not changing that cotangent of x into sine of x over cos of x over sine of x. And then we just sorted out the fraction. Let's try another one from your homework. Let's do number 3 from your homework now. And again, I want you to try this on your own. And I want you to use one of those techniques. Either On one side of the equation, change everything into sines and cosines. So either use the sine and cosine technique or multiply by a conjugate, or multiply by one, by a special one based on a conjugate. For instance, this has got a conjugate. This one's conjugate is where there's a minus, you write a plus instead. But you have to multiply by the number 1. So you have to have the same thing, top and bottom. You can either do that with the left side, or you could use the conjugate of this side. And the conjugate of this side is where that's a plus, write a minus instead. And this has to be, this bit you're putting on, this extra bit you're multiplying in has to be 1. So this has to be the same. Not the same as that, the same as here, okay? So I'm going to give you 2 minutes and sort this problem out for me. Use one of those techniques and just see where it goes to. It doesn't matter if you don't finish it, you've just got to try. Okay, so on this one, I'm not going to tell you yet how I know, but on this one, I'm definitely not using the sine and cosine technique. I can just look at that and immediately go, oh, I need to use the conjugate method. Okay, and I'm going to tell you how I know that soon. But I know I'm going to use this method. That's going to be what sorts it out for me. Okay, so I could use either the left or right side. I'm going to use this one just because I've got more room to write it. So I'm going to multiply that by cosecant of x minus 1 over cosecant of x minus 1. So it's perfectly valid math because all I've done is multiply by the number 1. So let's sort that out. Now, it would be perfectly valid math to distribute that there. But can you see why we shouldn't? Look at what we're aiming for. This is our goal. We want cosecant of x minus 1 in that numerator. So to distribute would ruin something that we want. We'd end up having to undo that by factoring it out again. So I'm not going to mess with the numerator at all. I'm just going to leave the numerator exactly how it is. But I am going to change the denominator. Let's write out that numerator. Remember, you have to write out the full expression every single time. Now, why we introduce difference of squares, why we introduce the conjugate is we actually bring in difference of squares, which is a really powerful technique. And what it's going to bring in is if you multiply that out by FOIL, you get cosecant squared x times cosecant squared x. The outer and the inner would give you plus cosecant squared plus cosecant x minus cosecant x. They cancel in difference of squares. And then the last term gives you plus 1 times minus 1, which is minus 1. So when you multiply by the conjugate, you bring in difference of squares. And this is going to bring in one of your Pythagorean identities, which is going to really help you clean stuff up. Now think about it. That's what we call the cheesecake. Have you seen cheesecake there? That's our cheesecake Pythagorean identity, which is I cut cheesecake. 1 plus cot squared x equals cosecant squared x. Now that's not what we've got. We haven't got that exactly. When you bring in difference of squares, you're bringing in something based on this side of the equal sign. This side is sum. You can make this side be difference of squares by getting one of these terms from the other side and subtracting it over there. So what we're obviously doing on this one, we want to subtract 1. So we have to subtract 1 from this side, and we're left with the cotangent squared of x. When we see cosecant squared of x minus 1, it can be replaced with cotangent squared of x because of that identity. So let's put that in then. We've got cotangent of x times cosecant of x minus 1 all over, we said that was the same thing as cotangent squared of x. Look at our goal, we're almost there. We only want a cotangent on the x, cotangent, not a cotangent squared. But look, we've got a plain old cotangent at the top. If I expanded this, wrote it as two separate factors, cotangent x times cotangent x, one of them would simplify. This is a little bit of overkill, writing out this line, probably doing more than we need to. But for some of you not sure what's going on, hopefully this makes it clearer. So at this point here, this is a factor of the entire numerator. Either of those are factors of the entire denominator. I can cancel these with either one of those. And we are left with what we were aiming for, which is cosecant of x minus 1 over cotangent of x. If we look back at the top, that is what we were aiming for. Let's just write it down at the bottom. So we've got our identical twins, and we have just verified or proven or shown that that is an identity. It's true for all values of x, okay? So we finished. Right, now, I promised you I was going to tell you how I know which technique to do. Let's look at those two problems we've just done, and I'll show you what I was seeing. When I look at this, I'm just looking at how many terms there are in each fraction in the numerator and the denominator, and I'm looking at patterns. In this one, on both of them, I've got a fraction equal to another fraction, yeah? But on this one, in that fraction, there's just one thing on the top, and there's something minus something else on the bottom. When I look at the other side, I've got the same thing. I've got one lump on the top, another lump minus another lump on the bottom. The pattern is basically the same. Both sides have the same pattern. Write this down so that you know what to read over when you come back to it. Both sides have the same pattern. That means they're not very different. You do not need a big change. A fairly simple change is going to solve this for you. All you need is a fairly simple change. And the simplest technique we really have to work with is that sine and cosine technique, where you rewrite things with what they're equivalent to in terms of sine and cosine. Now, if we look at the pattern of this one, the question 3, on this side, we've got two terms on the top, cosecant x minus 1. There's two things on the top. There's only one thing on the bottom. On the other side, we've only got one thing on the top, and we've got two things on the bottom. Their patterns are totally different. The pattern on each side is different. You're going to need to totally and utterly change the pattern on one side so that it can match the other side. You're going to need a big change. And what brings in a big change is using that conjugate. Using a conjugate to bring in difference of squares. So you're going to bring in a 1. Like on this one, you would multiply by a carefully chosen form of 1. Whatever that blob plus blob is, you do blob minus blob. And you'd have to do the same on the top, yeah? So that's how I know when I look at them. Let's have a look at the whole homework and not solve them now. Let's just go and have a look and decide, see how you can use that identification of patterns to know what your first step will be. It really can cut down about 5-10 minutes work on some of these problems. But there's actually 3 techniques. There's 3 patterns. These are the 2 we've just looked at, and I've not drawn it as carefully in the same way. This is supposed to represent one thing on the top, 2 things on the bottom. That's the pattern is the same on both sides. This is the one, I'll call this technique B, where you're going to just write both in terms of sine and cosine. Just use reciprocal and quotient identities, bringing sines and cosines. This is the one where the pattern is different on both sides. We'll call that pattern C, use a conjugate. Sometimes you're also going to get this. where you have two totally separate fractions on one side and just one fraction on the other. And I hope that's obvious. What you're going to do when you've got that is combine those two. Bring these two fractions together over a common denominator. Then you'll end up probably with a monster fraction equals the fraction on the other side, and you just clean up that monster fraction. So let's just briefly look at each of the homework questions and see what we'll do. So we've done number one. Can you see the pattern was this? Same pattern on both sides. Use the sine cos technique. This one, we had blob minus blob over blob equals blob over blob plus blob. Totally different pattern. Use, well, we'll call that was B, method B. This one we're going to use the conjugate technique because the patterns are different. We need a major change. Ooh, I can't even spell conjugate today. We'll just call that pattern C. Okay, need a major change. Let's look at number two. Can you see you've got something minus something over something plus something, and on the other side you've got something minus something over something plus something. The patterns are the same. All you're going to have to do on this one is use the sine cosine technique. Technique B. What you're probably going to do is you're going to probably replace those cosecants using their reciprocal identity that cosecant theta is 1 over sine theta. And you're going to end up with fractions inside fractions, and you're going to have to clean up that fraction. But at least you know how to start the problem. Look at number 4. Can you see you've got two separate fractions on this side and one fraction on that side? This one, you're going to have to combine those fractions together over a common denominator. It's arbitrary, how I call them A, B, and C. That's going to be what I was calling technique A, combine over a common denominator. Take about a minute and decide what you would do on 5, 6, 7, and 8. Okay, so number 5 is the least obvious of these. This doesn't look like a fraction, it just looks like number 1, but it is a fraction. You've got two totally different fractions on this side and just one thing on the other side. So this one, you're going to combine those two fractions together. You're going to write 1 as a fraction, and you want it to have this denominator. So your first step is going to be to write that 1 as 1 plus cos theta over 1 plus cos theta. So that's going to be using what I'm calling technique A. This one, can you see the patterns are the same? So you're just going to use the sine cosine technique. And in fact, what you're going to actually be changing is those secants, write them as something else, okay? And then this one, can you see the patterns are the opposite? This one, you've got 1 over something like that. So this one, you're going to use the conjugate technique. And this one, it's the same pattern on both sides. Two things added on the top, two things subtracted on the bottom. So this one, you're just going to use technique B, the sine cosine technique. And yes, it might involve some horrible work with fractions, but at least you know not to even bother trying the conjugate. If you start using the conjugate on this, you're going to get a great big horrible mess, and you're going to go down a rabbit hole. Okay, so that's how we know which one to do. Now, what I'm going to do with you now is I'm going to do one of these questions with you. Choose one more of your homework questions, type in the number you want me to do. We can either do 4, 5, 6, 7, or 8, and I suggest you choose either 4 or 5. All of you, type into chat. Do you want me to do number 4 with you or number 5? So let's do question number 5. Oh, here's some terrible math. Please never do this. I'm not going to do it all for you, but look at this. Cancel out the ends. So my answer is obviously 6. There you go. That's a joke. That's not real math. Please never do that. I see some really weird things when people never cancel terms. Every time you do that, a kitten dies. That's horrible. It's a meme on the internet. Right, let's do number 5. Okay. So when I look at this, I can see I've got these two things on this side and one on the other. So I'm going to have to combine those together over a common denominator. So turn this into a fraction. And my common denominator is going to be 1 times 1 plus cos x. And I'm combining two fractions separated by subtraction. This first numerator has to be multiplied by this denominator. So I've got 1 times 1 plus cos x, and I can do that in my head. If it's more complicated, maybe you need to write that out, yeah? And the other numerator is just being multiplied by 1. This numerator is already over that denominator, so it's not going to change. Okay, and remember we're aiming for cos x. We've really got to simplify this down. So now we need another hint. When you look at this, I hope you're starting to recognize what the hints are. I'm seeing this squared. As soon as I see squared, that makes me start thinking of my Pythagorean. So you don't have to write this. This is what you're thinking in your head. I'm thinking about, because of that squared, I'm thinking about a Pythagorean identity, and the one that's got sine in it goes sine squared x plus cos squared x equals 1. So I don't want sine squared x plus cos squared x, I just want sine squared x on its own. So in the actual identity, I have to take cos squared x from both sides. So I know, you can think through this just in your head. You get really fast at it, doing it in your head. When I see sine squared x, it is equal to, so can be replaced by 1 minus cos squared x. So this sine squared x, I'm going to replace with 1 minus cos squared x. But you don't have to write this work here out. That's just what you're thinking in your head. What you do have to write out is exactly what was written there, just with our substitution. Okay, and this sine squared x here, I'm replacing with 1 minus cos squared x. Now, I've made a fatal error there. I can't get the question right now. Can anyone see what it is that I've just done that's wrong? What I've done wrong is I was supposed to subtract all of this. So that when I'm subtracting, I have to distribute that negative. I'm not just subtracting the 1, I'm subtracting all of it. So I'm subtracting the negative, that minus needs to be turned into a plus. Distribute the minus, that turns into a plus. So let's look at what we've got here. Adding 1 and subtracting 1 are a 0 pair. They cancel each other out. So now I've got cosine, all I've got left is cos x plus cos squared x over 1 plus cos x. Now, that's not really helping, or is it? I've got to get that all the way down to cosine of x, so I need another clue. That's my clue. Look at where I'm going for. I don't want this denominator. I've got to get rid of it totally. Can I cancel it out? What would I need to be able to cancel it out? I need the same thing on the numerator, and all I want to be left with is cosine x. When you look at it with that in mind, that all I want is cosine x at the top, and I want this to go, can you actually see what we need to do? We need to factor the numerator. Both this term and this term have got cosine of x in common, so I can factor that out. So in the numerator, I'm factoring out cosine of x. If I'm factoring it out, I pull it to the front and I divide both terms by it. Now you don't have to write that bit out that I've written in green, but some of you aren't really great at factoring, so hopefully that's helped. This turns into the number 1. This turns into cos x. I really would prefer it if you didn't do all that stuff that I did in green on that, if you can just think through that. Okay, and now there, because we've got this fully factored, there's multiplication, and the entire numerator has a factor of 1 plus cos x, and that's the same as the entire denominator. You can only cancel out the entire factor, not little bits of it. So that factor totally cancels that factor, and I'm left with cosine of x equals cosine of x. Okay, so we're done.